So this is our subject, data engineering, and in continuation of previous videos, today we'll be focusing on data engineering skills and activities, data maturity stages, the background and skills of a data engineer inside an organization. So coming to the skills and activities of a data engineer or data engineering, undercurrents of data engineering life cycle, that is security, data management, data ops, data architecture, and software engineering. He should also know how to evaluate data tools, how they fit together across the data engineering life cycle. A data engineer should be able to juggle the complex parts and optimize along the axis of cost, agility, scalability, simplicity, reuse, interoperability. So what a data engineer is expected to know, he is expected to know monolithic technologies such as Hadoop, Teradata, Hive, and related. He should have the understanding of software engineering, networking, distributed computing, storage. A data engineer is also expected to create agile data structures that evolve as new trends emerge. What a data engineer does not do is directly building the machine learning models, creating reports or dashboards, perform data analysis, build key performance indicators, or develop software applications. He should have the functioning understanding of all these areas. Anyhow, what is data maturity? It is the progression towards higher data utilization, capabilities, and integration across the organization. So a newly started company may have better data maturity than a 100-year-old company. It may happen. Data maturity models have different versions, like you have one version called as data management maturity model. And there are three stages in the data maturity model, that is starting with data, scaling with data, leading with data. When we are speaking about the first stage of data maturity, what we are speaking about data maturity. What we are speaking about data maturity model. The first stage of data maturity model is starting with data. So they are the early stages of data maturity. Data architecture and infrastructure are at the early stages. Adoption and utilization is nearly extinct or not there. The teams are very small. A data engineer has to play a role of a generalist, means he'll be doing this and that, and maybe he'll play the role of a data scientist also, a data analyst also, kind of. But here the role of a data engineer and the goal of a data engineer is to move fast, get traction, add value. In the first stage of data maturity, which is called as the starting with data, so a data engineer must focus on the following things. Get buy-in from stakeholders, including the executive management. Define the right data architecture, determining business goals and competitive advantage. Identify and audit data. Build a solid data foundation for future data analysis and data scientists to generate reports and models that provide competitive value. Here the challenges may be organization willpower, challenges may be communication, challenges may be heavy lifting, better to use off-the-shelf turnkey solution wherever possible, better to build custom solutions and code only when this creates a competitive advantage. The second stage of data maturity, we are speaking about data maturity, and there are three stages in data maturity, which are starting with data, scaling with data, and leading with data. The second stage of data maturity is the scaling with data. So now here what happens is scalable data architectures are being created, planning for a future when a company is genuinely data driven. So the ad hoc requests have been taken away, formal data practices are being adopted. And now the data engineer becomes a specialist from a generalist, and his special focus will be on particular aspects of data engineering life cycle. Now, uh, what a data engineer will be doing at stage 2 with, of the data maturity model. What is the stage 2 of data maturity model? That is scaling with data. Establish formal data practices, create scalable and robust data architecture, adopt DevOps and DataOps practices, build systems that support machine learning, continue to avoid undifferentiated heavy lifting and customize only when a competitive advantage results. The third stage of data maturity model, we are speaking about this diagram, which speak about the data maturity model. And this diagram says the data maturity model has 3 stages: starting with data, scaling with data, leading with data. We spoke about starting with data and scaling with data. Now we are going to speak about the leading with data aspect. Sorry. Now, at this stage, the company is data driven. Automated pipelines and systems created by data engineers allow us to do self-service analytics and machine learning. New data introduction is very seamless and tangible value is derived. Data engineers have proper control and practices to ensure that data is always available to the people and systems. Now, in stage 1, they were generalists, data engineers were generalists. In stage 2, they become specialists. Now, the specialist role becomes more deeper in leading with the data stage, which is the third stage. Now, whatever he was doing in the previous stage 2, the same thing data engineer will do. Along with that, he'll be doing the following also: creating automation, building custom tools and systems, focus on enterprise aspects of the data, deploy tools that expose and disseminate data throughout the organization. That can be data catalogs, data lineage tools, metadata management systems. Collaborate efficiently with system engineers, machine learning engineers, analysts, and others. Create a community and environment where people can collaborate and speak openly, no matter their role or position. Now, coming to the next topic. What is this topic? The next topic is the background and skills of a data engineer. Now, how should I become a data engineer? So, if you are a software engineer, or if you have ETL background, or if you're a database administrator, if you're a data scientist, if you're a data analyst, then transition becomes easier for you. What a data engineer does, he deals both with technology and data. Now, coming to data, he has to follow the best practices about data management. On the technology end, a data engineer must be aware of various options for tools, their interplay, and their trade-off. This requires a good understanding of software engineering, data ops, and data architecture. A data engineer must also understand the requirements of data consumers, that is data analysts and data scientists. Coming to the business responsibilities, he should know how to communicate with non-technical and technical people. He should understand how to scope and gather business and product requirements. He should understand the cultural foundation of Agile, DevOps, DataOps. He should be able to control costs, learn continuously. So, for him, communication is vital, bigger picture is vital, interacting with technical, non-technical people is vital. Coming to the technical responsibilities, he should understand how to build architectures that optimize performance and cost at a higher level. He may use pre-packaged or homegrown components. Coming to the stages of data engineering life cycle, we know that there are 5 stages of data engineering life cycle: data generation, data storage, data ingestion, data transformation, data serving. Alongside that, there are 6 undercurrents, that is data security, data management, data ops, data architecture, data orchestration, and software engineering. Now, whether a data engineer should know how to code? Yes. He should also be able to play around with open source. He should also be able to play around with plug and play SaaS. What programming languages a data engineer should know? The primary programming languages he should know are SQL, Python, JVM, Java or Scala or Bash. The secondary programming languages can be R, JavaScript, Go, Rust, C, C++, C#, and Julia. Now, in data science, there are two notions of data scientists, type A and type B. Okay, where A stands for analysis and B stands for building. Similarly, you have type A and type B data engineer. Here, type A data engineer means A stands for abstraction. Type B data engineer means B stands for building. A type A data engineer manages data engineering lifecycle mainly by using entirely off-the-shelf products, managed services, and tools. Type B data engineer builds data tools and systems that scale and leverage a company's core competency advantage. Coming to the next topic, data engineer within an organization, inside an organization. Okay, so a data engineer inside an organization can be internal facing or he can be external facing. An external facing data engineer aligns with users of external facing applications such as social media apps, Internet of Things, e-commerce platforms. He should architect, build and manage the systems that will be collecting, storing and processing transactional and event data from these applications. He should have a feedback loop from the application to the data pipeline, then back to the application. This is the external facing data engineer system role, where the data engineer has a loop back thing. An internal facing data engineer focuses on activities crucial to the needs of the business and internal stakeholders. So he'll be creating and maintaining data pipelines, data warehouse for BI dashboards, reports, business processes, data science and ML models. In practice, internal facing data is usually a prerequisite to external facing data. So we have covered today for the subject data engineering the following topics: data engineering skills and activities, data maturity stages, the background and skills of a data engineers inside an organization. Thank you.